Hey guys, today we're going to be tackling further mechanics 9231. The basics of momentum is going to be the first concept, and yeah, by the end we are going to be able to do all of basics of the momentum, two body collisions, wall collisions, and then we can even tackle a past paper question, just so that we're familiar with how questions are going to be dealt with. So back to it, we're going to deal with basic of momentum first, so that we may understand how momentum works. So in case that you've not taken IGCSE physics, you would see that momentum is actually denoted by the letter P. Okay, the momentum is your mass times velocity. Okay, and it's a vector quantity, meaning it has a magnitude and it has a direction. Okay, now with that said, if a 5 kg object, 5 kg, was moving with a speed or velocity of 3 meter per second towards the right, what is the momentum of the object? So you're going to do 5 times 3, which is equal to 15 kg meter per second. This will be your momentum. That's the unit for momentum. Now in the case that this 5 kg object, there's another 5 kg object, okay, is moving this way towards the left with 3 meter per second. Now what is its momentum? Well, the magnitude of the momentum remains the same, but remember, we considered the going towards the right to be the positive direction, meaning when you look over here, this means positive, this means negative. Okay, so in this sense, if it's going this way, it's actually just going to be negative. So it will be 5 times minus 3 equals to minus 15 kg meter per second. So what does minus kg meter per second mean? It means it moves towards the right with negative 15 kg meter per second. Okay, when you have the minus, you can flip the sign, and that tells me it moves to the left with 15 kg meter per second. So yeah, you can choose your way of calculating it, but this is the fundamental of momentum. Now with more to that, yeah, now we have two body collisions or wall based collisions. Let's deal with two body first. So let's say that you have a ball. Okay, this is of mass 2 kg. Okay, and it hits a ball at rest. This is a 1 kg ball. 1 kg. Okay, at rest, and this one is moving with the speed of let's take our 4 meter per second. Okay, now this is what happens before the collision. Okay, now you should understand that what happens before the collision is pretty much what happens during a collision. So during the collision, the two balls are going to be like this. They're about to collide, or they are colliding. Let's label them A, B. So in this case we'll have A and B on the floor. This is 2 kg, this is 1 kg, and yes, this is striking B with 4 meter per second. So this is what happens during the collision, and then after the collision, it's going to be a bit different. So now naturally, what do you think is going to happen if you roll a ball towards another that is at rest? Well, both the balls will start moving now. So that means A, B. Now after the collision, assume that it's proper, A is going to move with some speed v1 and B is going to move with some speed v2. Okay, we don't know what it is. All we do know is that when you collide the ball A with B, you're going to get the ball B moving and you're going to get ball A moving. Okay, now how do we find out the terms as it is? It's very simple. Firstly, we look, let's make like a column just for this. Okay, so yeah, for before momentum, let's find the total momentum. Okay, so here's the principle of the conservation of momentum. The initial momentum, so Pi, equals to the final momentum, which is Pf. Now this does not mean that the initial momentum of one body is equal to the other body's final momentum. No, that's wrong. What this actually means is that the total momentum of the system. Okay, now what does that mean, you may ask? Well, the system holds two bodies and only those two bodies can have momentum. No other body can. Now among these two bodies before the collision, can you tell me which one would have momentum? It's obvious, because since this is at rest, this is 0 meter per second, by the way. Since this is at rest, P equals to mv. Okay, P equals to mv would yield 0 momentum for B, because it is simply not moving. A, however, can move. So we're going to write the total momentum as Pi, initial momentum, and that's just going to be mass times velocity plus mass 1 times velocity 0, which is 8. So your total momentum is 8 kg meter per second. Now I should say that this applies even during the collision. During the collision, the same thing applies. This is how the questions are actually asked during the exams. They put two balls A and B and then very close to each other like this, instead of representing it like this. And there's a reason for it that's coming soon. I'll tell you right now. Yeah, and then the final momentum is Pf. So the final momentum would be, well, A's mass is 2, so 2 times v1 plus v2. So what do we get out of this? Since Pi, the initial momentum, equals to the final momentum due to the principle of the conservation of momentum, or POCM, okay, this is the principle that we use. Initial momentum equals to final momentum, so that means 2v1 plus v2 equals to 8. That is how this entire thing works. This is going to be your momentum formula. Now there is something, there is a little bit more to it. Okay, now we're going to be introducing something called the coefficient of restitution. Now what does that even mean, you may ask? Well, let me just tell you that coefficient of restitution, E, not Euler's number, but the actual, it's an actual variable. Okay, yeah, coefficient of restitution, E, is speed of separation divided by the speed of approach. Now you may ask, what is the speed of separation and approach? Okay, I'm going to come to that very soon. So let's take an example of okay, let's say two balls. Okay, let's disregard their masses for a second. Okay, this is moving with 1 meter per second. This is moving with 2 meter per second, this way. So now they're coming towards each other, 1 meter per second, 2 meter per second. If we were to write a momentum formula, fine, let's write this as Km, and this is going to be M. If we were to write a momentum formula, we would state that the total momentum would be the momentum of A plus B. So momentum of A would be K times M times 1, and we add that with the momentum of B, which will be mass M times, now we can't write 2 because it's going the other way. Instead, what I would like to do is, whenever you have a velocity vector acting in an opposing direction, we would consider one direction to be positive. So in our case, we considered going from here to here, okay, considering from here to here as positive, and that means this to this is negative. So what I would like to do is convert this 2 meter per second into this 2 meter per second. It works the same way. Okay, you're just converting the direction. When you flip the direction, the sign changes. So we write -2 meter per second. Okay, we don't need to write meter per second, and that's the initial momentum, which is Km minus 2m. This is the initial momentum. Now before a collision, there is an additional value we can calculate. speed of approach, VA. VA, sorry. But yeah, what is VA? Well, judging by it, you tell me. Okay, let's think about it about two people. Okay, this is person A, and there's another guy over here. This guy is person B. They're both on the same plane like this. Okay, now this guy moves 1 meter per second. This guy moves 2 meter per second. So what is the speed of approach, you may ask? Let's say that the distance between them is 9 meters. Okay, so if I took 1 second, okay, if I waited for 1 second, person A would move 1 meter and person B would move, well, 2 meters, right? So now the distance between them is now 6 meters. So we know how the velocity of the whole system can be different of the individual bodies. So if you look over here, in 1 second the guy travels 1 meter, meaning 1 meter over 1 second equals to 1 meter per second, and this gives us the velocity of A. Okay, this gives us the velocity of A. Now over here we move 2 meters and in 1 second, so this gives us the speed of B. Speed, okay, not the actual velocity would actually be negative, but yeah, let's move on. So yes, you can see that how it's 1 meter per second, 2 meter per second, but now if you look closely, they are now 6 meters apart. Now if I did this again, 1 meter and this one went 2 meters, they would now be 3 meters apart. And then among that 3 meters, you take another second, it will move 1 meter like this, and he will move 2 meters, and they would finally meet. So they were able to move 9 meters in 3 seconds altogether. So your total speed is 3 meters per second. Basically, they covered a distance of 3 meters every second. So in the first step, he moves 1 meter and B moves 2 meters. So now instead of 9 meters, they are now only 6 meters away. So they were able to move a total of 3 meters altogether. Okay, they were 3 meters closer now. Due to that, we can say that's 3 meters every second. So we get 3 meters per second as the speed of approach. This works really well, and yeah, it's just another way of saying that if you have a velocity v1 and you have a velocity v2 both in these directions, you can say it's going to be v1 minus v2. Okay, yeah, and in this sense v1 would be equal to 1, v2 would be equal to minus 2. Remember, v2 should act in this direction, so v1 would be 1, v2 would simply be this thing flipped, so it will be this way, minus 2, and then you do v1 minus v2, which gives us 1 minus minus 2, which gives us 3 meters per second as the speed of approach. Okay, this is really simple. Now let's proceed to what happens after collision. So after collision, let's consider this again. Consider this to be two different balls. This is moving with a speed of 1 meter, maybe 1 meter per second, and this one's moving with a speed of 3 meters per second. What is the speed of separation? Well, consider this. There are two runners. Okay, this is person A. There are two runners on a track, person A, and this is another person, person B. Okay, now in the very first second, okay, by the way, the speeds correspond to the runners. Okay, so in the very first second, this guy manages to travel 3 meters and this guy managed to travel only 1 meter. So you can see that they separated by about 2 meters in the very first second. Now in the second, okay, that's a bit weird, but in second number 2, this guy moves at 6 meters, and this guy moves just 1 more meter, so he moves over here 2 meters. Now if you look at the speed, now if you look at the separation, the separation is 4 meters. So what do you notice about over here? You will see that for every second that passes, B covers 2 meters more. Okay, so in the very first second, B was able to cover 2 meters more than A. In the very second second, B was able to cover 2 more meters than A, meaning 2 plus 2, which is 4 meters over. So basically, we can see as how every second passes, B is 2 meters per second faster than A. Okay, it covers 2 meters per second more. Okay, so let's look at the speed of separation for a second. Initially, A and B are 2 meters, and now they move to 4 meters. Okay, they were at the starting position, and at second number 1, this is during at least 1 second. During this 1 second interval, they are now separated by 2 meters. So we can do 2 meters over 1 second equals to 2 meters per second as your speed of separation. And if we try to do the same thing for the second, so that would be over here to here. This is for 2 seconds. They're separated by 4 meters. And 4 meters over 2 seconds gives you the speed, and that's going to be 2 meters per second. So this, my friends, is what you call the speed of separation. Okay. So with that being said, let's see a few examples in which you can find the speed of approach and separation. So once again, how speed of separation is done is actually, well, if this is moving with the speed of v1 and this is moving with the speed of v2, it's going to be v2 minus v1. This gives us a speed of separation. Okay, vs. And if you were to find the speed of approach, if it's moving with v1, v2, if you are supposed to find the speed of approach, VA, you would be getting V1 minus V2. This is going to be the speed of approach. Okay, now it's important to consider the direction vectors. Okay, and if an object is at rest, we can just consider V2 to be 0. Okay, so with that said, you're now ready to tackle so many problems from now on. Keynote, remember that we consider the right hand side to be the positive direction. Meaning that if you have 1 meter per second this way and 5 meter per second this way, and they're about to collide, obviously, otherwise they wouldn't be together like this, you will see that this 1 meter per second is in the positive direction. It's moving from negative to positive, and this one's moving from positive to negative. So in order to flip that polarity, we need to actually convert this into a new system, which we don't change 1 meter per second, but we change this 5 meter per second into negatives. We need to make sure, because so that it is in the formula we are able to accept. We can only accept formulas in the form of well, 2 simultaneous arrows towards one direction and then v1, v2. So in this case, you can see how it works. Now both these directions are the same, and both of these are considering what we call the positive direction. Remember, you can also consider the this side to be the positive and this to be the negative, and then you would have to flip 1 meter per second. So it will become negative 1 meter per second, and this would be 5 meter per second. So yeah, you could consider that way as well. Then you would have to do v2 minus v1. In that sense, we'd have to do v2 minus v1. Okay, that's why I like to use this way and this way, because they both consider one direction in particular. But with that said, we usually just do the velocity that's behind minus the velocity that's forward for separation, and we do the velocity that's forward minus the velocity that's backward for for separation, and this one's for approach. Okay, with that said, I think we're ready to go back to our problem over here. The speed of approach in our scenario over here, okay, VA, EA, is going to be, well, V1 minus V2. Now V1 is 4 meter per second and V2 is 0, so we can say that the speed of approach is 4 meter per second. Now VB is going to be, well, forward velocity minus backward velocity, in which both of them move in the same direction. So this will be V2 minus V1. So if I was to write the coefficient of restitution, I would say E equals to V2 minus v1 whole divided by 4. That is exactly how I would write E as. Okay. Now, if they ever do give you your value of E, okay, we would officially have a simultaneous equation for v2 and v1. So let's consider the possibility. Okay, our first equation was 2v1 plus v2 equals to 8. Our second equation was E equals to v2 minus v1 over 4. So in this possibility, let's give us a value. E is equal to 1 by 2. Okay. Also remember that E can only take values between 0 and 1. Okay. Yeah, so that's it. Yeah, E equals to 1 by 2. So in that sense, we would get v2 minus v1 equals to 1 by 2 times 4, which is 2. And we write the second equation, 2v1 plus v2 equals to 8. Now with these equations, we can either do simultaneous equations or elimination, whatever sounds better for you. So in this case, let's consider substitution. v2 equals to v1 plus 2. Okay, so in that sense, it will be 2v1 plus v1 plus 2 equals to 8. Okay, and 3v1 equals to 6, v1 equals to 2 meter per second. Now we find v2. v2 is simply v1 plus 2, which is 2 plus 2, which is equal to 4 meter per second. So when you go back, you can see that this velocity of b is actually 4 meter per second, and velocity of v1 will be considered 2 meter per second. Now you shouldn't worry about what direction you took v1 and v2 as. For example, if I took v1 to be in the other direction like this, that wouldn't matter either, because then I would have to convert this into negative v1. Okay, negative v1 this way. And if I proceeded with my calculations correctly, I would get a negative value for v1, and that negative value of v1 multiplied by the negative here would give me a positive value for v1, which would be 2 meter per second. If we want, we can try that out. Okay, so let's go back. Same calculations as such. Let's say that this time it was moving with velocity v1 this way. Let's say that we considered it like this, v2. This is just to show you that the direction you consider your variable to be doesn't matter as long as you understand the magnitude. So we always consider the right hand side, the direction the right, as a positive. So we consider this to be negative v1, this to be positive v2, a, b. Okay, and let's consider the initial values. va equals to 4, because we are not touching the previous circumstance. Okay, e equals to 1 by 2. Now speed of separation vs would be a bit different, because in this case it will be v2 minus v1, right? This is how we consider speed of separation. vs equals to v2 minus v1, but that was when v2 was this way and v1 was this way. So in our case, v2 corresponds to v2, v1 corresponds to negative v1, because now it's finally in our direction and we get negative v1. So v2 minus v1, as in speed of approach, would actually be v2 minus v1, which is v2 plus 1. I know it's sorry, v2 plus v1, sorry, but yeah, this is going to be the speed of separation, v2 plus v1. So using the coefficient of restitution formula, 1 by 2, which is e, equals the speed of approach, speed of separation, v2 plus v1, divided by the speed of approach, 4. Okay, now we get v2 plus v1 equals to 2. Okay, now from here we can find our values. So v2 equals to 2 minus v1. We can use this, and now we can plug this into our momentum formula. Okay, now we didn't calculate the momentum last time, and let's calculate it this time. So the initial momentum was 8 kg meter per second. So let's calculate the final momentum of the system. Okay, so it will be mass, which is 2. This is 2 kg. So mass 2 kg, and this is 1 kg. So the momentum of this system will be mass, which is 2, times velocity, which is negative v1, because we're considering the positive direction, which is left to right, plus the momentum of b, which is 1 times v2, which is equal to 8, because initial momentum equals to final momentum. And then we get v2 minus 2v1 equals to 8. Okay, now with that being said, we can now use simultaneous equations. If we plug in v2 for this formula, we would be getting 2 minus 3v1 equals to 8, and v1 equals to minus 2. And if v1 equals to minus 2, v2 equals to 4. Now let's see if that compares to our previous values. 4 meter per second this way, that was true because we considered this to be right. And v1 is negative 2 to the left. Now negative 2 this way is simply positive 2 this way. So this was just to show you that whatever direction you take v1 and v2, it doesn't matter as long as you keep to your original direction all throughout the calculation. Because the moment I flip this way into this way, then my calculations are going to go wrong. You gotta have to settle with one formula in the beginning and go through it all the way. Now we're going to go a bit advanced. Okay, now we're going to actually move on to some more advanced two-body collisions. So now you know how velocities, especially during projectile motion, you know that if you launch with the speed of u with angle theta, the velocity actually has two components, a horizontal and a vertical component. Okay, now let me try it like this. What is the vertical component going to be? Well, using trigonometry, that's u sine theta, because u remains to be the hypotenuse, and the horizontal component is going to be u cos theta. Okay, so this marks the initial velocity of the projectile motion. Now here's a tiny law that you would know, that you should know at least. Let's say A and B are like this. Okay, A moves towards B, B is at rest. Now according to the line of centers, okay, you would assume that if they collided, B would be moving this way, and that's true. If A and B collided like this, then their only direction of motion would be this way and this way. B's direction could only be this way and this way because it was at rest. But if they collide like this, an object at rest, since it is moving directly to the horizontal, B can only move horizontally. Okay, so if we considered A like this, B like this, and A faces just right to get into this position A, where it can, so if you play it like snooker, you could tell that A moves just like this to hit the side of B, and then B moves horizontal like this, and A may move something like this or something like that. I don't know, it's different, varied on masses. Okay, but this is just to show that even a diagonal moving object can impose a horizontal velocity on another object. Okay, and that's very crucial to understand. It depends upon how you collide with the object, obviously. So if it's colliding like this, then the object which was moving horizontally can only move this way, and object A will only have a velocity, a horizontal velocity, in this way. Now why don't we say that A can't also move in the center? Because if A was launched with velocity u, it's moving and colliding with B with velocity of u cos theta, but it is moving down with the speed of u sine theta. So in this sense, B doesn't have a vertical velocity since it's only moving horizontally. Let's call this speed u. So we are taking A and colliding it with B with u cos theta. This is u cos theta, and we are taking B and colliding with A with speed u, such that they collide like this. So right now B would have a resultant of, let's say, v1. Okay, and that would be in the horizontal direction. v2, however, now based on horizontal collisions, we know that A should have a speed v2 as well. Now it can be this way or it can be this way. It doesn't matter which way you take it. Once again, direction don't matter unless you take the variable proper. Okay, so yeah, A should also have a v2 like this, right? Well, yes, it does have a horizontal component of velocity, like it can be 0 as well, but it does change because there is still that vertical velocity u sine theta that wasn't affected. And because that vertical velocity was never affected in the momentum collision, you would have the new speed, and that v, let's consider speed of a to be v2. The actual speed of v2 would be u2 whole square plus u sine theta whole square. Okay, and root that. Okay, you can just use the hypotenuse right angle triangle rule, and yeah, you get this. Okay, now where does this apply? Once again, I'm going to come to that soon. But now you know how to use the coefficient of restitution, you know speed of approach, you know speed of separation, we know how to calculate the basic momentum initially, we know how to calculate the final momentum Pf, and now we're going to look at one last thing before we tackle a past paper question, which is wall-based collisions. Okay, so what is wall-based collisions? Oops, that's a bit wonky. Let me just... Okay, yeah, let's say that we have a wall-based collision right here. So let's say this is A. Fine. Now let's say that the wall has a coefficient of restitution, E. So what's going to happen? And this is moving with speed u. So wall A, it collides with A, and then after the collision, A moves with speed v. Okay, after the collision, it moves at speed v. Find v in terms of u or whatever, blah blah blah. How would we do this? Very simple. You should understand that during collision with the wall, the horizontal, if it's horizontally colliding, the horizontal velocity u will now be like multiplied with e to get v, meaning e times u gives you v. So based on the coefficient of the restitution of the wall, we are going to get the velocity v. Now what do you mean by this? Well, E can take values between 0 and 1, right? Yeah, this is a domain that E can take values from. So in that sense, you could say that if E was equal to 1, U equals to V. And that's what we call perfectly elastic. Now what's so elastic about this? Well, let's say that this had mass m. Okay, mass m. If you calculate the kinetic energy, it would be half mu square, and this would be half mv square. So if E was equal to 1, you would get U equals to V as stated over here. And so half mu square equals to half mv square, meaning that the initial energy is equal to the final energy, meaning energy is conserved. So during perfectly elastic collisions, aka when E equals to 1, the initial energy equals to the initial kinetic energy equals to the final kinetic energy. That's all there is. That's the gist of all of this. Now if E was like 1 by 2 or something, if E equals to 1 by 2, your new velocity will just be a half times U. That's it. That's the fundamental of wall-based collisions. Now that obviously could be raising doubts. For example, if you have a wall like this, okay, and you have A moving at U angle theta, okay, what's gonna get affected over here? Because U has U sine theta here, and U also has U cos theta this way. Well, my friends, you should understand that E, okay, now U equals to V. This is the main thing that you should know. Okay, you should understand that this only applies when the velocity is perpendicular to the barrier or the wall. Okay, now when you consider A, we are saying that it has a velocity U cos theta this way, which is perpendicular to the wall, and then there's a velocity U sin theta which is parallel to the wall. So the velocity that is parallel to the wall will never get affected, and the velocity that is perpendicular to the wall does in fact get affected, and it follows this formula. So now since our final velocity of A, once it finishes colliding, let's say that it collides like this, and it leaves at an angle alpha. Okay, this is A, and it leaves at an angle maybe alpha or something, alpha, and it leaves at speed v. Okay, so with that being said, we can say that the horizontal component of A is going to be v cos alpha, and the vertical component is going to be v sin alpha. So what we should understand is that since the parallel sides, the parallel velocity remains the same, u sin theta would be equal to v sin alpha, but the horizontal velocities would follow this formula because they are perpendicular to the barrier. And since E, we can give an E to be, well, 1 by 2, we can say 1 by 2 times u cos theta. Remember, we don't take u because u is not perpendicular to the barrier. If this is u, this is not perpendicular, but u cos theta is in fact perpendicular. So 1 by 2 u cos theta equals to v cos alpha. That's the new horizontal component, okay, because it's perpendicular. So the perpendicular velocity will give you a new perpendicular velocity. Parallel velocity will be remaining the same if the collision is perpendicular and it's parallel to the vertical velocities. So in this sense, you would get u cos theta equals to 2v cos alpha. And from here on, you could actually go on and solve the entire thing. You could, but that's just a bit lengthy, and yeah, there's a lot of identities to do. What really matters is that you understand the fundamental concept. Now let's tackle a few questions on this. This is what war collisions were supposed to be, okay? So we could tackle a few questions, but I think we're ready for the past papers. Alright, so two uniform smooth spheres A and B of equal radii have masses 2m and m respectively. A is moving in a straight horizontal line with B with speed u, and B is stationary. Sphere A collides directly with sphere B, and they move in the same direction with speeds VA and VB respectively. After the collision, the kinetic energy of B is 9 by 2 times the kinetic energy of A. Show that VB equals to 6 by 5u. Okay, fair. So let's consider this. This is A. This is B. Okay, they're in the same. Okay, the first thing I would do is draw, because then I have an idea of what happens. Okay, this is of mass 2m, this is of mass m, moving at a straight horizontal line with velocity or with speed u towards B, obviously, because then you can't collide. B is stationary, so this is just 0 meter per second. Directly with this, and then they move in the same direction. Okay, so now we have to understand that we can't, now this time the direction actually matters. Okay, so now you can say that both of them are going to move in this way. Okay, and it would be illogical to use both the directions to the left hand side. Yeah, we technically could use both directions like this, and we could say this is VA, this is VB. We could do this, but realistically speaking, if you're going to throw a ball at an object, it will never move the opposite direction like that. It just defies physics. Okay, Newton's third law. So we don't use that. So we know the directions are confirmed. It's going to be this way. After the collision, the kinetic energy of B is 9 by 2 times A. So let's first understand a few things. They have not given us the coefficient of restitution, which means you don't need to find approach. You don't need to find the separation speed, nor do you need to find the coefficient of restitution, even if they didn't give us that. So let's try finding out something at least. Using the principle of conservation of momentum, POCM, you would see that the initial momentum is 2mu, because 2 times m times u gives you 2mu, plus mass times 0 is just 0. So this is the initial momentum, Pi, which is equal to the final momentum, Pf, which is equal to, well, this is 2m and this is m. So in the final momentum, it will be 2mva minus mvb, minus mvb. Okay, sorry, not minus, plus, my bad. But yeah, this would be the total momentum since both are in the same direction. So now we got a formula, 2mu equals to 2m va plus mvb. If we just cancelled out all the m's, we would get our very first formula. 2u equals to 2va plus vb. This is the very first formula that we can apply. Now moving on, let's look at something else now. The kinetic energy of B is 9 by 2 times A after the collision. Okay, after the collision is the keyword over here. So after the collision, the kinetic energy of A would be half times 2m times VA the whole square, and this is supposed to be KEA, basically the kinetic energy of A, and that's going to be mVA the whole square. Okay, and the kinetic energy of B, KEB, equals to half times mass times VB the whole square, which is equal to half times mass times VB square, like this. Okay, this is how the kinetic energy of B would look like. Now it says it's 9 by 2 times A, so that means it's just equal to 9 by 2 mVA the whole square. So now if we cancel out the masses, multiply 2 on both sides, we'll be getting VB square times 2 is equal to 9VA the whole square, and rooting both sides we get VB equals to 3VA. Okay, now we can use this formula. We could use VA equals to 1 by 3 VB, since they want us to find VB. So with that being said, we can use this in our initial formula over here. So we get 2u equals to 2 by 3 VB plus VB, that's equal to 5 by 3 VB. Okay, that's equal to 2u. So now we multiply 3 by 5 on both sides, we'll be getting VB equals to 6 by 5u. That's how you'd solve the first part of the stuff. Okay, now VB equals to 6 by 5u. This is a clue, by the way, because now you should understand that every question leads to another clue. Okay, so you need the previous value to find the next value, and that's what's going to show. B collides with a fixed vertical barrier. Immediately before the collision, it makes an angle alpha with the barrier, and after the collision it makes an angle beta with the barrier. Coefficient of restitution is 4 by 5. As a result of the collision, velocity is reduced to this. Find value of sine alpha plus beta. Fine. This may seem tough. It's very simple. It's free marks actually. But let's call this the object B. During the collision, let's look at the collision exactly. You can see that it would collide alpha with the barrier. Okay, this is how it would look like. Now using the parallel rule thingy, you would see that this is also alpha, and it moves with speed 6 by 5u from our previous value, 6 by 5u. So now we have a few values to consider. Okay, it says alpha with the barrier, so it's important to understand what values you're looking at. And then after the collision, it moves like this. Okay, this is B, and it makes an angle beta with the barrier, and coefficient of restitution is 4 by 5. Velocity is now 12 by 25. I'm going to call it V. Okay, so let's just look at the before collision very carefully. That's before the collision. You can see it moves at speed 6 by 5u and collides with a fixed vertical barrier, and it makes an angle alpha with the barrier. So it's important to understand that the ux, which is the initial horizontal momentum, horizontal velocity, which is going to be 6 by 5 u, and instead of sine the cos alpha like we normally do, this time alpha is on this hand side, so it's going to be 6 by 5 u times sine alpha, and uy equals to 6 by 5 u cos alpha. Now Vx equals to, now velocity v is actually 12 by 25 root 5u. So we get 12 over 25 root 5u. And yeah, if this is angle beta, this is the hypotenuse b, we would see that this is actually going to be the horizontal velocity is going to be v sine beta, and the vertical velocity would be v cos beta. Okay. Yeah, so it's going to be, this is supposed to be v, by the way, v, just for simplification, so v sine beta and vy equals to 12 by 25 root 5u cos beta. So what's the first thing I said? Any velocities that are parallel to the direction of the collision, that to the wall, is going to be the same. Now you can see that uy acts this way, vy would be this way. Okay, so with that being said, it's smooth calculations from now on. So yeah, vy equals to uy, so that means 6 by 5 u cos alpha equals to 12 by 25 root 5 u cos beta. Now we need to perform a few calculations. We can cancel u out, and we get we can multiply 25 all throughout. 30 cos alpha equals to 12 root 5 cos beta. Okay, and yeah, we could probably do a lot of calculations right now, but let's isolate cos beta first. Cos beta equals to 30 over 12 root 5 cos alpha, and we multiply root 5 on both sides. Okay, this is going to be a very interesting value. Okay, so 30 over 12 root 5 gives us root 5 over 2 cos alpha. Okay, so this is the very first equation that we have. Cos beta equals to root 5 over 2 cos alpha. To save some space, I'm just going to erase the working, but I hope you understood that the vertical velocities remain the same. Okay. So cos beta, let's use a different thing, just for I think better understanding at least. So yeah, cos beta equals to root 5 over 2 cos alpha. Okay, now we have to consider the horizontal velocities. Now it says that the coefficient of restitution is 4 by 5, and that tells us something, because now we have to apply the relationship eu equals to v, oreux equals to vx. So yeah, that's the new formula we have to apply. Let's use a different ink. This is the formula we have to apply. So ux is 6 by 5 u sine alpha. We times that with 4 by 5, so that's going to beeux, and that's going to give us 24 over 25. Okay, 6 by 5 times 4 by 5 gives you 24 over 25 u sine alpha, and this is supposedly equal to vx, which is going to be v sine beta, or 12 by 25 root 5 u sine beta. Okay, cancel u off, times 25 both sides, we get 24 sine alpha equals to 12 root 5 sine beta. Divide 12 by both sides, so you can get 2 sine alpha equals to root 5 sine beta. And yeah, now we can isolate the variable alpha or beta. Since we did cos beta this way, we'll do the same for sine beta. So we'll be getting 2 root 5 over 5 sine alpha equals to sine beta. Okay, so this is what you're going to be getting: 2 root 5 over 5 2 by root 5. Yeah, so this is the value you're going to be getting. Okay, so yeah, that is the fundamental thing. Now let's erase like most of the working because we have what we want. So yeah, so I hope you guys understood like how this thing works. And yeah, so yeah, sine beta equals to 2 root 5 over 5, or 2 over root 5 works the same way, and this is going to be sine alpha. Okay, so now we have sine alpha, sine beta. What more do we need? Well, if you want, you can look at things even more clearly now. You could match it with whatever you have here and here. Yeah, so cos beta equals to this, sine beta equals to that. Now you may ask, how do we proceed from here? Well, we should know that sine alpha plus beta is going to be sine alpha cos beta plus sine beta cos alpha. Okay, let's use a different thing. Let's use maybe yellow. Okay, yeah, so sine alpha remains the same. Cos beta is going to be root 5 by 2, so it's going to be root 5 by 2 sine alpha times cos alpha plus now sine beta. Sine beta is 2 root 5 by 5, like this, sine alpha. This is what sine beta is, and cos alpha, well, that remains the same. Sorry, this has to be cos beta and cos beta. Yep. Okay, and we can add the two components. You will be getting, well, now we have to do root 5 by 2 plus 5 by 2 plus 2 root 5 by 5. So root 5 by 2 plus 2 by 5 equals to 9 root 5 by 10 sine alpha cos alpha. Okay, so this is what we have over here, and this is what sine alpha plus beta will be equal to. Now if we need to find sine alpha and cos beta, we need to go back and look into our solutions. What gives us the clue of sine alpha and sine beta? Okay, so well, we could look into other stuff as well. So let's see, we have the horizontal velocity, that's going to be ux. We have the vertical velocity, that's uy. We have the velocity after, that's vy, same as uy. And we have the velocity after collision as well, the horizontal one, it's vx. Now it's just smooth sailing from here. We found the horizontal components of velocity, we equated them, we got values of sine alpha, cos beta, all that stuff, we did it. Okay, now it's just a matter of actually just solving the question. So find sine alpha, find cos alpha. Okay, now how would we do that? Well, now we need to look at all the relationships that we have before, and we need to consider it after. We can't use the energy conservation rule because, well, it's not said that the energy is guaranteed to be conserved. As in, energy would be conserved, but the kinetic energy is not necessarily conserved. Okay, we really can't say that the momentum, we can use the momentum formulas, but that doesn't really help out much. Okay, because then we would just be getting the mass of B as a factor into this. But yeah, we could get 6 by 5 mu equals times E equals to this, but it's going to be a bit weird. So we have to consider all the possibilities. Okay, and yeah, we can see over here Vy, Vx. Now here's going to be a bit of a I would say it's a bit confusing. Okay, but it's going to get a little bit more trickier here. So we're gonna have to apply a few relations over here. Let's cancel this for now. Okay. And yeah, okay. So let's replace sine beta and cos beta everywhere. Okay, so over here for sine beta we would be getting 12 by 25 root 5 times that with 2 by root 5 by 5, and this is what Vx is supposed to be equal to. Okay, Vx equals to 12 by root 25, 12 by root 5 by 25 times that by 2 root 5 by 5 u sine alpha. And yeah, we can just process this numerical calculation. I think it would be 24 over 25 u sine alpha. Let me just compute that on my calculator. Times root 5. Yeah, that's 24 over 25 u sine alpha. This is the final velocity horizontally, and Vy, now that's just going to be 12 root 25, sorry, 12 root 5 by 25 times that by cos beta. Now cos beta is root 5 by 2 cos alpha, and yeah, we can do this also. Times root 5 over 2, that's going to give me 6 by 5 u cos alpha times u cos alpha. Okay, and yeah, from here on out we can just proceed with calculations. So we square these two values up and equate them to something, and yeah, now let's do it. So 12 by 25 root 5, this is the target that we had to achieve. Okay, so squaring this gives me 576 by 625 u squared sine squared alpha plus 36 over 25 u squared cos squared alpha. Okay, and this is supposed to be equal to 12 by 25 root 5 the whole square, which is 144 over 125 u square. Okay, now let's cancel some of the ink over here because it's wasting some space. Okay, yeah, let's take it with red again. But yes, now we can simplify the formulas, do whatever we want. We can cancel out u square out of the entire equation. We can multiply everything with 625, so we get 576 sine squared alpha plus, now 625 times 36 over 25 gives us 900, so 900 cos squared alpha equals to 144 over 125 times 625, which is 720. Okay, so now we just change values. So we know that sine squared alpha equals to 1 minus cos squared alpha, and so we get 576 minus 576 cos squared alpha plus 900 cos squared alpha, okay, equals to 720. And yeah, now doing this we get 900 minus 576, so 324 cos squared alpha equals to 720 minus 576, which is 144. So cos alpha will be equal to the root of 144 by 324, which is equal to 2 by 3. So if cos alpha is equal to 2 by 3, using the relationship for sines and all that stuff, we would be getting sine alpha to be root 5 by 3. Okay, root 5 by 3, And yeah, we did use that entire relationship before. That's a huge relationship after that, but okay, now let's simplify this. So we have sine alpha equals to root 5 by 3 and cos alpha equals to 2 by 3. So we have massive clues here. Okay, this is enough to solve the equation. We have sine alpha, we have cos alpha, and we also have the necessary values to find out sine alpha plus sine beta. Sorry, sine alpha plus beta. Okay, yes. So let's just write down what we know so far. Sine alpha equals to root 5 over 3. Cos alpha equals to 2 by 3. Now sine beta equals to, now let's find out sine beta. Sine beta, since we know sine alpha, I think you're going to be getting 2 by 3, and cos beta should be equal to 2 by 3 times this, so cancel, root 5 by 3. Okay, great. Okay, perfect. So we have 4 values. Now are these values enough? Yes, it is, because looking at our sine alpha plus beta identity, we would be getting sine alpha times cos beta plus sine beta times cos alpha. Okay, so sine alpha is root 5 by 3, and we times that with cos beta, which is root 5 by 3 as well. We add this with sine beta, which is 2 by 3, times cos alpha, which is also 2 by 3. Okay, so this gives us 5 by 3, and now we have to add that. Wait, no, this gives us 5 by 9, my bad. This gives us 5 by 9, and this gives us 4 by 9. And so sine alpha plus beta equals to a beautiful 1. And that was how we solved this, and it was basically free of 6 marks, because all you had to do was find out the horizontal velocities after collision, use the Pythagoras theorem. So we know that the velocity of this and this, okay, so we found Vx in terms of this, and we found sine beta. We just replace that over here to get in terms of sine alpha. And once you did your entire calculation, we get Vx, we get Vy in the similar fashion, which is just this over here. We do the squaring rule, so Vx the whole square plus Vy the whole square, so equals to V square. We can use Pythagoras theorem, find V. They've given us V already, so yeah, we're all chill. It's a really easy way to solve and get marks. It's really fantastic. I would highly recommend that you guys practice as much as you can, because this is the freest marks you can ever get. With that being said, that marks the end of this video, how to solve momentum based questions. I hope you enjoyed, and feel free to share any doubts that you have in the comments, and yeah, see you until next time.